Hello everyone, my name is Arya Devdar and this is part 1 of NCERT Class 10 Science, Chapter 2, Acids, Bases and Salts. Okay, so this is the second chapter of your chemistry section of your NCERT textbook, right? So we have already covered the first chapter, like chemical reactions and equations. So this is the second chapter. This is again a very important chapter for your boards. There are many theories and reactions involved in this chapter. So you have to understand every minute detail of this chapter because I'm afraid that from this chapter very confusing questions are framed and they are asked, right? So make sure that you understand every part. Okay, so let's start. So in this part, we are going to see a brief introduction of acids and bases. We are going to start with a brief introduction of acids and bases, correct? After that, we'll see what exactly are indicators. Okay, so we'll move on to indicators. So there are three types of indicators. We'll see each one in detail, correct? And after indicators, we are going to see the identification of acids and bases using indicators. So what color change occurs when an indicator is added in an acid or a base? That's what we are going to see in the last part. Okay, so let's start with the brief introduction of acids and bases. So what exactly are acids and what exactly are bases? So they are, in short, they are chemical substances, right? In like brief, they are chemical substances, correct? And you have already studied about them in your 8th or 9th standard, so in your previous classes. So this part is just a revision of those classes, you can say, right? Whatever I'm going to write now here. So there are many theories regarding what exactly are acids and bases. So there is for example, the Bronsted-Lowry theory, or there is the Lewis acid-base theory, right? But you'll study about all of that in your higher classes. For now, you only have to study the characteristics of acids and bases, right? So let's start with acids. What exactly are acids? See, acids, they release hydrogen ions in water. Okay, so the first property, release H plus ions in water. So we'll study more about this in the upcoming parts, right? A little more in detail about this. But for now, just understand they release H plus or hydrogen ions in water. Correct? They also have a sour taste. Now this you know. They have a sour taste, right? They, for example, you have vinegar, right? Or you have a lemon or an orange. So all of them, they are sour in taste. So all of them contain acids, different types of acids, citrus acid, acetic acid, etc. Okay, so acids usually they have a sour taste, correct? They also have a pH below 7. pH value is less than 7, correct? This also you might have studied, but we are going to see deep dive into this in the further upcoming parts, okay? And the next one is that they turn blue litmus paper red. Turn blue litmus red, correct? Okay, so some examples of acids, okay, examples. So we'll see the chemical formulas here. For example, we have HCl, we have H2SO4, we have H3PO4, we have CH3COOH, etc. Correct? So let me write down the names of all of these acids. Okay, so HCl, yeah, here we go. HCl is hydrochloric acid. Hydrochloric acid. H2SO4 is sulfuric acid. Sulfuric acid. H3PO, it is phosphoric acid. Phosphoric acid. CH3COOH is acetic acid, right? Acetic acid, or the like This is the common name, and the chemical name, actual name of it is ethanoic acid, right? So these are a few examples of acids. Now we'll move on to bases. So what exactly are bases, right? Let's see more about that. So bases, again, bases, they release hydroxide ions. They release hydroxide ions. Hydroxide ions and basically OH minus, right, in water. Okay, so as I have written, for acids, they release H plus ions in water. So bases release hydroxide ions in water, ions. So that is OH minus, right? Other than that, bases, they have bitter taste. Okay, bases, they have a bitter taste, correct? They also turn red litmus paper blue. Yeah, also they have a pH above 7. Right, so great. That is basically greater than 7. A pH greater than 7, right? And they also turn red litmus blue. Correct? Okay. So now some examples. Examples of bases. They include MgOH twice, KOH, NaOH, CaOH twice. And then there is obviously there are soap and all those other things, but I'll not write that down here. We are only writing chemical formulas, right? So we have CaOH twice. We also have caustic soda, washing soda, all of that, but I'm not writing that down here. Okay, so these are the main bases here. So this, I'll write down the names. This is magnesium hydroxide, magnesium hydroxide, sorry, right? This is potassium hydroxide. This is sodium hydroxide, correct? NaOH. So this is one of the most strongest bases. Okay, and COH twice is calcium hydroxide. Okay, so see, these are some examples of bases. So this was a brief introduction about acids and bases. We'll be going more into detail in the upcoming videos about what exactly are acids and bases, right? So you'll understand more about them from their chemical reactions or their chemical properties, basically. So these were just some of the physical properties here, right? So anyways, now let's move on to the next topic, which is indicators. So what exactly are indicators? Like, what is the actual meaning of indicators? So you know that indicators are basically substances which change their color in presence of an acid or a base. So that is like the definition, formal definition of indicator. So you can write an indicator is a chemical compound, or you can write as a substance, whichever is suitable, is a chemical compound that changes its color, changes its color in presence of an acid, presence of an acid or a base. So this is the formal definition. It is very easy to understand, right? Indicators. Correct. Now there are three types of indicators. Okay, so the first type, so I'll just draw a flow chart here. I think that would be suitable, right? Indicators. And then there are three types, right? The first type is natural indicators. Okay, the second type is synthetic indicators or artificial, whichever you want to call them. And the third type is olfactory indicators. So they are broadly divided into three types: natural, synthetic, olfactory. So as you can guess from the name, natural indicators, they are the indicators which are made from natural substances. Correct? Natural indicators. Okay, so Some examples of natural indicators. I'll just write down made from or produced from natural organic substances. Substances. You can also write derived from natural organic substances, right? Or extracted from, I'm sorry, extracted from natural is also fine. Anyways, yeah, so some examples of natural indicators include litmus paper or litmus. Litmus is basically like some information about litmus. It is a purple dye actually. Litmus solution, it is a purple dye and it is extracted from lichen, right? A plant which is, I think, a thallophyta in the plant kingdom, right? And it is very commonly used as an indicator, as I've written even in the definition of acid and base or the properties, right? Red litmus and blue litmus, how the acid bases, you know, it affects them. So those are basically natural. It is basically natural because it is derived from lichen, right? Lichen is a type of plant. Okay. So litmus, other than that, we have turmeric, right? Turmeric is also a great indicator. We have many flowers as well. For example, we have hydrangea, petunia, right? So all of these flowers petals, if they are dipped in an acid or a base, they change their color basically. Okay, so these are some natural indicators. Okay, moving on to synthetic indicators. Synthetic indicators are basically chemical substances which are produced in the laboratories. Okay, produced in laboratory. Right? Chemical substances, synthetic, artificial indicators, and they change their color in presence of an acid or a base. Synthetic, right? So some examples include phenolphthalein, methyl orange, and then there is the universal indicator. Right, so universal indicator is basically a yellow piece of paper, right? So just like litmus paper, right? So it is a yellow piece of paper. Now when it is dipped in the acid or a base, it changes its color to match the pH level, right? So you know that the pH level is associated with a color graph. So red is acid, blue or purple is base, right? So you might have seen it. So that is the color which it changes to, the universal indicator. So hence it is called universal because it is the same worldwide, right? So universal indicator, it is a very commonly used indicator, universal indicator, right? So yeah. Now we'll move on to the third type, which you might have not heard before, right? Olfactory indicators. So what basically are olfactory indicators? So these are the substances whose odor changes in acidic or basic media. Okay, so olfactory indicators are those which change their odor in presence of an acid or a base. Right, so some examples of olfactory indicators are vanilla essence, right? Vanilla essence, then we have cloves, and then we have onions. Onions also change their scent or their odor. Right, so when these are brought in contact or like they are dropped on an acid or a base, right? Mixed with an acid or a base. So basically, in an acid, all of these olfactory indicators, they retain their smell, right? They keep their smell. But in bases, if they are put in bases, they do not, they like lose their smell. We cannot smell it. We cannot smell the vanilla essence in base. Right, so that is how we can identify whether a substance given it is an acid or a base. Okay, so these are the three types of indicators: natural, synthetic, and olfactory. Okay, so now we'll move on to the last part, which is identification of acids and bases using indicators. So we'll see the color change, how the color change occurs, right? Of four important indicators in acids as well as bases. correct? So firstly, phenolphthalein. Phenolphthalein, if you know, it is a colorless solution, right? So if this colorless solution, it is mixed with acid, it remains colorless. Nothing happens. But if it is mixed with a base, it turns vibrant pink color. It turns really pink. Okay, so in very strong bases like NaOH or KOH, it turns like really magenta pink color. But in weak bases, it turns like a light pink, but still it changes its color basically. Okay, methyl orange is basically orange in color, right? So in acids, it changes to red, right? So this orange color, it changes to red, and in bases, it changes to yellow. The orange color, it changes to yellow. Okay, methyl orange. Now moving on to blue litmus. Now the rest two are quite familiar. You are already quite familiar with it. Blue litmus, in acids it changes to red color, right? And in bases it remains blue. So blue litmus is basically blue, right? You can understand that. Red litmus, it remains red in acids, and in bases it changes to blue. Correct. So this is the color change or the identification. How can we identify acids or bases using indicators, right? And also you have to understand that for salts, like I'm just giving you a brief description. For salts, nothing happens. No color change. So phenolphthalein will remain colorless in salts. Methyl orange will remain orange in salts. Blue litmus will remain blue. Red litmus will remain red. No color change in salts, right? Okay, so that's it for this video. We'll see more next time. So thank you so much.